This video is going to take us through what happens when we are approaching a vertical asymptote and the graph itself is not approaching a value, but it's approaching positive or negative infinity. So we're going to first look at the graph 1 over x squared. Take a minute to just sketch that graph. Notice in red there are asymptote lines, vertical and horizontal, and that we're going to really focus on the vertical here. The horizontal is another type of limit that we're going to be looking at. Your domain for this graph is negative infinity to 0, union 0 to infinity, with parentheses because we have that break at 0 due to the vertical asymptote. So our focus in this lesson will be the vertical asymptote. We do have a horizontal asymptote, but again, this will be our focus for today. All right, so we're going to use our table to find the limit as x approaches 0 of 1 over x squared. So we'll go back and do table ask. I already have it on the ask mode. Let's get rid of this here. It's annoying in the bottom screen here. Okay, so we're going to go to second table. We have some stuff in there, and just as I did in class, I forgot to put in the function. So we're going to do alpha y equals, switch out to our new function, and other option that works just as well, 1 over x squared. If you don't have the alpha y equals, as long as you don't have two things in the numerator or denominator, you actually don't need parentheses. Okay, and now I'm going to switch out these values. Remember, if you want, you can delete them or overwrite them. So I'm going to do -1, -0.1. In fact, actually, I'm going to eliminate that first one. So we don't really need that. We're going to start with -0.1. We're trying to get close to 0. -0.01, -0.001, and then we'll put 0, knowing we're going to get that error message. Now in this version of the calculator, that's as many values as I'm going to get. So I'm just going to write in those answers here. Kind of look at what's happening as we get close to 0. Now for the -0.001, we actually have 6 zeros we want to put there because it says E6. So 1, 2, 3, 4, 5, 6. Then at 0, we get our error message. So you'll notice the balance in our table. We have the error now because of the vertical asymptote. And we can look at this with our graph visually and with what's happening with the table. But as we get closer to 0, our numbers keep getting larger, where our arrows are pointing us towards positive infinity. So something to note with this, the limit does not exist. In order for there to be a limit, we have to reach a real number. But what we want to talk about is what's happening. So it's similar to what we did before when we were approaching a number. Here we're trying to go towards 0. And when we do that, we can make f of x greater than any other number, or positive number, by taking x, we will remember this next phrase, sufficiently close to 0 but not equal to 0. So we have that phrase again, sufficiently close. And greater than any other positive number is really talking about infinity. So we're going to say that the limit equals infinity, but infinity is not a real number, so it still does not exist. I'm going to use this little symbol for, which means therefore. We say the limit as x approaches 0 of 1 over x squared equals infinity. But technically the limit does not exist. DNE is a nice shortcut for does not exist. Since infinity is not part of your real numbers. Writing positive infinity as the limit tells us it increases without bound, and there is a potential for it also decreasing. Okay, so we're going to take a look at, that's the intro question. We're going to take a look at a second video to do a few examples of how we will approach this with some of the different problems we'll be looking at.